All right, Mr. Bromley, I believe you are up to introduce our next speaker.
I am, and I am excited to introduce our next speaker too, because we're about to talk about, let me be careful with my wording here, massive scale. And I'm pretty excited to see what Pete's got lined up here for us. Pete, you there with us? Oh, let's not advance too far. I don't know if Pete's ready just yet.
Hey, yeah, I'm here.
There he is. Hey, Pete. So, hey, everyone. I'm here to introduce, and I'm happy to introduce Pete Bryan, or Peter Bryan, as Zoom saying, either one of the two. And Pete's here today to talk to us about building a hunting program at global scale. And I'll make a mention that he's a senior software engineer at Microsoft. And I got to be honest, Microsoft over the past couple of years has reached scales that I just, quite frankly, absolutely boggles my mind when I think about some of the issues you guys have to face and some of the things you've got to deal with. So thanks for joining us today. And with that, I'll let you go ahead and jump right into it so we stay on time. Ladies and gentlemen, Mr. Pete Bryan from Microsoft. Take it away, Pete.
Cool. Thanks, Matt. So yeah, today I'm going to talk to you fairly briefly about something we've been doing for the last 12 to 18 months, which is creating a hunting program that our customers can use. Pretty much any customer anywhere in the world. And this has kind of a number of challenges with it. And they're ones that I think that are pretty much applicable to any organization doing threat hunting and trying to build a hunting program. And particularly anyone who's trying to do it over more than a single team or a very small group of people. So the challenge that we got set was effectively to share Microsoft threat hunting knowledge and expertise with our customers. Within Microsoft, my team, the Threat Intelligence Center, obviously does a lot of threat hunting, but there are numerous teams that do different sort of hunting over different data sets, looking for different things. So we wanted to kind of take all of that and bring it to our customers. Then obviously being a cloud provider, it needed to scale and be pretty big. It needed to work for a range of our customers. So everyone from the kind of Fortune 500 customers down to the smaller SMB teams that might just have like a very nascent hunting capability. And it needed to work across all of their data sets. So we didn't want it just to be a sort of thing that worked only on Microsoft data, only Office AD, things like that. Instead, we wanted it to work with any sort of data set. And this was primarily built for our Cloud SIM platform, which ideally can take any sort of data. But as I'll talk about in a little bit, we've built it out to support other data sets, other SIM providers as well. And then the final thing is we wanted to make it accessible to every analyst. So we didn't want to make this a kind of high tier capability that only kind of 3 or 4 teams in the world are going to use. We wanted to elevate every security team with this capability and help them access threat hunting and leverage some of these more advanced techniques at a lower level and just generally improve security of everyone out there. So the first challenge we came across was really that hunting isn't a technique per se, it's a process made up of multiple techniques. And creating something for a technique is quite easy and quite well defined. If you look at security tooling or even just cloud services, they're focused on like, here's a technique. So creating something that worked for a process was a little bit different for us. And the way we thought about it was what is out there that helps kind of build a process. And Jupyter Notebooks were the obvious choice. They've been gaining momentum in security the last few years, but they're a really good kind of flexible way of setting a kind of process, but without forcing people to just do one thing. They give you the flexibility that you can go and do other things, you can edit them, you can add to them, you can do what you like with them. But whilst keeping this all within like a single contained element, a kind of threat hunting element. And we really like that. And internal teams at Microsoft had been doing threat hunting and incident response stuff with notebooks for quite a while. And we had a whole kind of bunch of tools and processes around that internally. So it kind of made sense to take that platform we're using internally and share it kind of out with our customers as well. It also helped that we have a cloud version of notebooks up in Azure as well. So we already kind of had the ready-made platform to work with. So for those of you who aren't familiar with Jupyter Notebooks yet, what they are is basically a browser-based code execution environment. you have in your browser, you have these cells that you can run code in and then see the output below. And you can chain these outputs into kind of building blocks that build up to stuff. You can kind of add visualizations, anything that you can do in the code, you can pretty much do it in the notebook. And then you can also add markdown cells to add documentation stuff. And then you can save these out as kind of records of the hunt you've done, say, with all the steps you took and all the data output, which is super useful for sharing and for showing what you did. Like if you want to show an incident response team, hey, here's a threat I found that you need to go deal with. Here's all of my workflow that I just went through to get there, all the data, you can look at it yourself. Here's a notebook. I would highly recommend go check them out if you're not familiar with them already. There is a bit of a barrier to entry, like you do need to know some code. Python is the most common one with notebooks, but they do support other things as well. You can even run PowerShell in some of the Azure notebook stuff now, which is pretty cool. So after we kind of got over that initial challenge of, hey, what do we do this on? We kind of ran into the problem of notebooks are quite hard to share. So it's great for sharing once you've kind of done the process, but they're not great for sharing kind of like a templated process. Like you can share them, but since you run them, you edit them, you have issues versioning. If you run notebooks regularly, what you'll find is you end up with like 80 different versions of the same notebook, or with like new updated V2. Like my list of notebooks is a mess. And then that created problems at scale. Like what if we wanted to go back and update one of these notebooks with a new feature or just updated for whatever data set we were working on? How do we share that out with customers? Because we're going to have to send them a new notebook, but then how will they know versions, et cetera, et cetera. So our solution with this was to take all that code we put in notebooks and take it out of notebooks, and instead move it to packages. So we have a couple of Python libraries that we created, one called MSTIC, which is kind of like our core repository of the tools that we use for security analysis, things to kind of get your data, handle authentication, basic visualization. And that's kind of applicable to pretty much anyone using notebooks anywhere. And then what we did, we created another library called MSTIC Notebooklets, which my colleague Ian came up with. And these are really cool. And what they are is, rather than kind of those individual techniques, they are chunks of those techniques in a short process. And these are short processes that you'll come across time and again when hunting. So for example, quite often when you're hunting, you'll come across a host name that you might want to know a little bit more about. And what you'll do is you'll run some code to kind of get a summary of that host for you. Now, typically what you do in notebooks is you would end up copying and pasting code from some other notebook you've written into this one. So what we did is we just took those blocks and put them into notebooklets. So now, again, you can just call them in one line, which makes the notebook that you're running it in a lot easier to use, a lot cleaner to look at. But also it's now a central location. So we can update those notebooklets in real time. And basically each time you pull down a new package of the library, you get all of those notebooks down for you. And then finally, obviously, we wanted to distribute this stuff. So we stuck it all into GitHub, our favorite place, obviously, so that at least we've got some kind of like central repository for these notebooks. It's not ideal because as soon as someone clones that repo, you kind of lose all of that. But at least it gives a central place where people can go back and say, hey, we wanted that threat hunting process they created. Let's go to get the latest and greatest version. So challenge number 1 and 2 were kind of the easy ones. They're the technology-based ones. And really, they're probably the ones that you can replicate most easily internally. If you start using notebooks, like creating your own library or finding a library that does what you need is relatively straightforward. Having a local Git server with all your notebooks in, again, pretty straightforward. Challenge 3 is a bit trickier. And this basically comes down to the fact that you can't write a hunting hypothesis for other people. You can give them ideas, you can suggest areas they look at, data sources, things to look for in it. But a hypothesis, to be effective, needs to be really targeted on an organization, their context, their threat model. So in essence, what we decided to do is not write a hypothesis for them and not focus on that. And instead, what we did is focus on the common areas that apply in threat hunting, regardless of what your hypothesis is. So this kind of data flow diagram, it was a threat hunting process diagram I found from Gartner, which I thought kind of covered what I was looking for quite nicely. I think, as Ben mentioned in the last talk, everyone defines threat hunting slightly differently. But this one, I think this diagram kind of covers broadly what I'm looking to talk about. And what we did is, rather than focus on the bits in orange, the kind of create a hypothesis or the output, we focused on those steps in blue, the discovery, the identify, the investigate, those bits that are repeated time and time again, and focused on building that. Now, you still obviously need that hypothesis, and really that's what we're helping our customers to bring. We're providing that via non-technical means, so like blogs and training and documentation about ideas for this. And we still want to work in this area. We're doing some other work about how we can help kind of create hypothesis for people. But really, certainly for our initial phase, we've kind of left that to the side really, and focused on those bits that people are going to do time and again. This again helps for particularly more advanced teams as well, because it gives them flexibility to bring their own ideas and to do things slightly differently. Because again, one of the values of threat hunting is the fact that you can be flexible. You follow your intuition. You don't necessarily just follow the prescribed SOC incident handling playbook, say. And we didn't want to create a process for people to use that kind of broke that flexibility, that ingenuity. And by focusing on those core kind of modules, and by making the bits of the process modular, we managed to retain that without kind of guardrailing people too much to a specific process or answer. And so what we did is focus on those things that you kind of use time and time again. So one of the things that we really liked internally and a lot of teams used was the ability to kind of timeline events to look at them. So we built a module that is now part of MSTIC that creates these interactive timelines for you. And you can pass it any sort of data. It can be discrete events, like logon events that we're looking at here. It could be things like network traffic over time that's voluminous. And you can just easily and quickly plot it on a graph with a line for you. The same with things like anomaly detection. So anomaly detection is a really powerful ML capability for threat hunting. It can form a really kind of good starting point. So rather than kind of create a anomaly detection for a specific data set or a specific environment, we created libraries and features that allowed you to apply it to multiple types of data set. So my colleague Karishma created this anomalous sessions anomaly detection, which can take any sort of sessionized event. So it could be Exchange PowerShell commandlets, which this example is built off, but it could be syslog, could be Windows event log data. It could be anything where you've got those sessions and those events. And as you can see, we love this timeline. Here we're using it to visualize those anomalies, but pretty much every single notebook we create has a timeline in it, as well as some of the other kind of common bits we created. So the fourth challenge came down to barrier to entry, and I alluded to this earlier. Notebooks require you to kind of have some coding knowledge, and whilst that's kind of fine for a lot of people, particularly teams that are a bit less developed, maybe have fewer people, so a narrower set of skills within their team, it is a bit of a barrier, and they can look quite daunting, particularly if you get a notebook that's fully formed, it's got loads of code that you don't necessarily understand. It can be a bit of a turn off for people. So what we did for that is to try and make it as familiar as possible. So we created a lot of these interactive widgets in Python that allow you to interact with a notebook in the same way, or at least a similar way you might with a UI in some other security tools. So we can have things where you pick a date time range with a slider and drop downs, you enter the host you're looking at in this example in just a little text box. And again, this is all just familiar for people, so it's a much easier on-ramp for them. what we also found is by moving stuff to the Python libraries that I mentioned earlier, we hide a lot of the code. This makes the notebooks a lot cleaner and a bit less daunting for people when they first approach them. And again, because these notebooks are flexible, we can share them in this way so people can pick them up and use them. But a kind of a power user who's really familiar with Python, say, they can just take out these sections and hard code stuff they want in. Again, the real power of having notebooks as our core platform is that flexibility and that kind of customizability depending on what skills you have. The other thing we obviously did as well is kind of document this stuff as much as possible through blogs, through documentation for the Azure Sentinel SIM product, and also the documentation for MSTIC Pi and MSTIC Notebooklets, our open source Python libraries. And again, we found that whilst there's lots of great stuff out there for notebooks and lots of great stuff out there for threat hunting, the overlap of those two currently at the moment is quite small and is often quite kind of focused on one particular technique someone's used as part of a threat hunt. So we said we should just document as much as possible about everything to give people that on-ramp. And the other thing we've done is, if you, the bottom left and top right in this slide, excuse me, they're the starting point or the opening cells of our notebooks. So we put a lot of documentation into the notebook itself to talk people through what it's doing, how to use it, what it means. Now, we found not a lot of people actually read that stuff, which can be quite frustrating, but we still think it's useful to have it there for people. And hopefully over time, people will kind of realize the value of that a little bit more. Challenge 5, everyone's data is different. So again, as I mentioned before, our challenge was to create this kind of threat hunting program that worked across loads of different types of data, not just Windows data or Azure data. And the thing is, everyone's data is a bit different. And even if it's the same, they might bring it in slightly different ways. It might be parsed or processed slightly differently. So how do we deal with that? Now, a few people on my team have gone through the process of creating parsers for things in the past and were very adamant that we weren't going to do that. We weren't going to create a common data schema for people because it's just a world of pain. It's hard to scale. It's hard to keep updated. So instead, what we did is focus on this common data language. Excuse me. And by that, what I mean is focusing on some small common schema elements rather than defining a whole schema. And then having a common interface for that. So we picked Pandas data frames because they're highly flexible and super usable. And what this allowed us to do is take all of those kind of features and techniques that we're using in our notebooks and create a common output and input of a data frame. So using our library, you can query data from, say, Splunk or Azure Sentinel or other places. It comes back in a data frame. You want to visualize it in our timeline. Well, the input for the timeline is a data frame. So that kind of interface is done for you. And then what we did is just focus on the bits of common data that we need. So for example, in the timeline, if you just want to display discrete events, effectively the only thing you need is the time of the event and the kind of field that you want to differentiate by. So the categorized field that you want to maybe split events by. That doesn't mean that you have to then define in your schema, a kind of a hard-coded field for each one. Instead, when you call the timeline, you pass it the data frame and you say, this column name is your time, this column name is your category. And the timeline just built it out for you. And that's been really, really useful for us. It makes it super flexible, super easy, new data set. All you need to know is 2 elements of that data set. Off you go. And again, because data frames are so popular as well in the Python ecosystem, if you want to plug in another data set, it's really easy to get it into a data frame. Like you might want to load just a local CSV file. Great, Pandas supports CSV into data frame. Then you just pump it into the rest of the tools. And that common interface is probably the most useful thing that we've done in all of this process. This challenge is kind of interesting. And again, the last speaker alluded to this as well, in that the definition of threat hunting is a little bit different for everyone. So creating a program or an output for a program that suits everyone is going to be hard. So again, what we did is focus on having a common terminology across everything we do so that people know what an output is and input is, keep it defined. And secondly was by keeping it in notebooks, we can show what we've done. This isn't a black box, find me something. This is a step-by-step process where you can show at each stage what you've done. And people can look back and see the process we've done and validate our output. We also make the notebooks as interactive as possible, allowing people to go down kind of different paths and pivots, depending on what they're looking for from the threat hunt. And again, to keep it accessible to everyone, we have kind of default values. So if you just want to go through our process and see what we find with what we've put together, that's fine. But if you're a bit more experienced, you've got that flexibility to do your own thing. So in summary, kind of what can you learn from our process and the journey we've been on for your own hunting program? Well, the first thing I'll say is focus on the journey of hunting and not the output. Don't think about what you want your threat hunters to find. Focus on how you want your threat hunters to work, and then build the program to fit that. Secondly, keep it modular. Don't force your hunters down a process. Allow them to pick the process and build it and keep it flexible, because that's the real value of hunting. Pick a common platform for them. Keep it familiar for them, so it's as common to what they use elsewhere. And then think about the sharing and versioning bit early. So those first couple of slides where I talked about how we shared notebooks and creating the package, doing that early rather than at the end is going to be key, because otherwise you're going to kind of create a world of problems for yourself later down the line. So that's everything from me. That's a very quick run through of everything, but obviously if you've got questions, we've got time now, but otherwise I'll be in the Slack channel for the next half hour or so.